How do spacecraft land on Mars successfully? Imagine flying through space at thousands of miles per hour, then suddenly needing to land on a planet with a thin, dusty atmosphere and rocky terrain. How do we make that happen? That's what we're here to find out. Landing on Mars is one of the most difficult parts of any mission. It requires precise planning, smart technology, and a lot of careful execution. When a spacecraft approaches Mars, it enters the atmosphere at about 12,500 miles per hour. That's faster than most commercial jets fly. To survive this fiery entry, the spacecraft uses a heat shield. This shield is made of special materials that absorb and dissipate the heat from the friction with the atmosphere. It protects the craft from burning up during this intense phase. Once the spacecraft slows down enough, the heat shield is jettisoned, and a parachute is deployed. The parachute is large, often as wide as a football field, and it helps slow the descent further. For smaller robotic landers, airbags are used to cushion the impact. These airbags are like giant inflatable cushions that surround the spacecraft. When the lander hits the ground, the airbags absorb most of the shock, allowing the craft to bounce and roll to a stop safely. This method worked well for missions like the Mars Pathfinder and the Rovers Spirit and Opportunity. But for larger, heavier vehicles like the Curiosity and Perseverance rovers, a different approach is needed. These rovers use a system called the sky crane. It involves a rocket-powered descent stage that slows the rover's fall. As the rover nears the surface, a tether lowers it gently to the ground. Once the rover is safely on the surface, the sky crane flies away and crashes at a safe distance. This system provides precise control and helps ensure the rover lands exactly where scientists want it. Thinking about future human missions to Mars, understanding these landing methods is key. Astronauts will need to land safely on the Martian surface, just like robotic missions. Training for these landings involves simulating the conditions they will face, including the thin atmosphere and rocky terrain. Engineers are also working on new landing systems that could make future crewed landings even safer and more reliable. So, landing on Mars is a mix of high-tech equipment, careful planning, and proven techniques. Each mission teaches us more, bringing us closer to the day humans will walk on the red planet.